today we're going to learn about adding and subtracting fractions. All right, our objective is to add, subtract fractions, and this is page 16. Now this is going to be kind of similar to when we compared fractions. We're going to start by finding a common denominator. And you can do that by taking your two denominators and then listing multiples. So when I listed the multiples of 3 and 5, I got that 15 was a common multiple, so that's going to be my common denominator. Again, I took this fraction, wrote it here, and said, okay, I know my new denominator is 15, so how am I going to get here? Well, I know 3 times 5, or I can also count 1, 2, 3, 4, 5. So this is times 5, so I need to do the same thing up here, which is where this 5 came from. 1 times 5 is 5. Then I use the same thing with the second fraction, 2/5. How do I get from 5 to 15? Well, this time, 5, 10, 15, that's times 3, or 1, 2, 3. So I do the same thing up here. 2 times 3 is 6, so that's where this 6 came from. So now I have my two new fractions that are divided into the same size part, and I can actually add them now that they have the same denominator. So 5/15 plus 6/15, I'm going to add the numerators. 5 plus 6 is 11. And the denominator stays the same. The size of piece that it's chopped into is not changing, so that's why you're not adding the denominator, okay? So let's actually try this with another example. Okay, well I know I'm going to start by finding the common denominator, and you might be able to tell already, and if not, that's okay. Go ahead and start by just listing some multiples of 6. 6, 12, 18, 24, 30. Okay, I'm going to stop there. I'm not going to actually list multiples of 5 because I know from my divisibility rules that any multiple of 5 will end in a 5 or 0. Well, that just means I know 30 is going to work because it's the first number that ends in a 5 or 0. So 30 is going to be my common denominator. So I'm going to take my first fraction, 1/6, and set it equal to something over 30. And I'm going to take my second fraction, 4/5, and make it also equal to something over 30. So now I need to figure out, well, how did I get there? 6 times what? Remember, you're only multiplying or dividing when you do equivalent fractions. You can't add something or subtract something. All right, so 6 times what is 30? Well, 1, 2, 3, 4, 5. 6 times 5. So do the same thing to your numerator. 1 times 5 is 5. Then I need to do the bottom. 5 times what is 30? Well, you could count by 5s, or hopefully you know, 5 times 6. So then this would also be times 6. So 4 times 6, well, you could also look up here. 1, 2, 3, 4. It's 24. Okay? Now I have my two new fractions. We have 5/30 plus 24/30. And remember, my denominator doesn't change, so that stays the same. And now I just add the numerators. Well, 24 plus 5 is 29. And I would want to see if I can reduce it, but in this case I can't. So I'm done. 29/30. All right, why don't you go ahead and get a head start and try this one on your own. All right, so again, you can list multiples of 7 and 5. 7, 14, 21, 28, 35, and I know 35 is going to work because it ends in a 5 or 0. 5/7, 3/5. New denominator is 35. How did I get there? Well, you can count up here, or you should know that 7 times 5 is 35. So we're going to do times 5 up here. 5 times 5 is 25. Same thing to my bottom fraction. I need to rename it so that I have the number of equal parts is 35. How did I get there? This would be times 7. So 3 times 7 would be 21. Okay, now I'm going to take my two new fractions and I'm going to add them. So 25 over 35 plus 21 over 35. Again, I know my denominator stays the same. And now I need to add 25 and 21. Again, you can always come up and write this and add carefully. These just happen to be ones that are kind of easy to add. So 5 plus 1 would be 6, and 2 plus 2 is 4. Now, I need to do one more step in this case because I can see that this is improper. So to really put it in simplest form, I want to make it a mixed number. And remember back to when we went over that, to change this back to a mixed number, we divide. So 46 divided by 35, that's going to go in once. I subtract 1, 1. Now remember, you don't have to keep going to a decimal or anything. We're just trying to find out how many equal times it goes in, and it only goes in once, okay? So then I can make that backwards V, 1 and 11 35ths. So my answer would be 1 and 11 35ths. All right. Next one, we're going to do the same concept that we've been doing, except we just need to subtract now instead of add. All right. So looking at my denominators, I can see that I have 12 and 4, and 12 actually will work because 4 goes into 12. So I know that 12 will be my new denominator. If I have 7 twelfths, I really don't need to change that because it's already in twelfths. Now if you want to, you can show this times 1 times 1, but see, it stays the same. So really you can just know that it's still going to be 7 twelfths. And then the 1/4, now that's going to be twelfths. How did I get there? 4 times 3 is 12. So 1 times 3 is 3. Okay? Now I'm going to write them. Make sure you keep them in the order they are. 7 twelfths minus, now my new fraction, well, same fraction, but renamed, is 3 twelfths. Okay? Now, again, the denominator doesn't change, so that's still going to be 12. And now, instead of adding the numerators like I did here, I just subtract them. 7 minus 3 is 4. Now, I want to go one step further and reduce this to simplest form. So 4 twelfths. Again, I can think about, well, what's the largest number that goes into 4 and 12? Well, 4. So divide by 4 over 4. And that would be 1, and 12 divided by 4 would be 3. So my answer in simplest form is 1/3. Okay, go ahead and try this one and see how you do. I can list multiples of 6 and 9 to find a common denominator. So 6, 12, 18, and this would be 9, 18. So there you go, I already found it, 18. So I'm going to write both of my fractions here, 5/6 and 4/9. And I'm going to rename the fractions so that they're now divided into 18 pieces. So how do I get from 6 to 18? Again, if you list out multiples, you can just count, or know that 6 times 3 is 18. So 5 times 3 is 15. And then do the same thing. New denominator is 18. How did I get there? 1, 2 times 2. So 4 times 2 is 8. All right. Now I need to subtract these two fractions. 15 over 18 minus 8 over 18. Denominator stays the same, and now I just subtract 15 minus 8 to give me 7. Okay, now last one, this is kind of a precursor to what we're going to learn next, is what if I have mixed numbers or improper fractions, either way. What if I have that? How would I correctly add or subtract those? Well, There's a couple ways, but the way I recommend is to start by changing them to improper fractions. So let's go ahead and do that. Remember, we can use Texas popcorn. You live in Texas, and hopefully you like popcorn. So 9 times 5, 45, plus 2, 47, over 9. All right, and then now we need to do Texas popcorn over here. Texas, remember, for adding and multiplying. 3 times 2, 6, plus 2, 8, over 3. Okay, so now I have 47/9 minus 8/3. Well, I still have to start by finding a common denominator. So I've got 9 and 3. Well, 3, 6, 9. 9 would work as my common denominator. Again, I'm not going to have to change this fraction because it's already in ninths. So yay. Let's just write that down, 47/9. I do need to change this one, so 8/3 equals how many ninths? This would be times 3, this is times 3, and that would be 24/9. Okay, now I take my two fractions and I subtract them. 47/9 minus 24/9. And again, I know that 9 will still be the same, so now I just need to subtract this. So be careful and make sure you're subtracting carefully. I'm going to just write it down right here, 47, 24, subtract. 7 minus 4 is 3, 4 minus 2 is 2. So that would be 23/9. Okay, now, last step, I need to change it back to a mixed number because it's improper. So, I do that by dividing. 23 divided by 9. Well, 9 is going to go in twice, which is 18. Now I subtract. 8, 9, 10, 11, 12, 13, so that's 5. And now I just have to make the V, okay, don't keep dividing to a decimal. So start at your answer, 2 and 5/9. And remember, the denominator doesn't change, so it'll still be ninths here. All right, keep practicing, and I'll see you next time.